So what makes a bolt, or any metal part, freeze or seize up? Compression, thermal variations, and electrical interrelationships can be contributing factors in varying degrees. But most of the time, fasteners freeze in place due to oxidation between the threads. Just plain old rust. And loosening these stuck metal parts generally comes down to one thing: the ability of a lubricant to penetrate into infinitely small spaces in often inaccessible locations. At the microscopic level, oxidation in fasteners leaves the threads pitted and scarred. These irregularities mechanically lock the threads into place. Rust then fills those irregularities and acts like sand to increase friction between the threads. Penetrating lubricants chemically dissolve rust while lubricating damaged threads. But the trick is to get the penetrant deep inside the rusted fastener. So what is it that makes a penetrant lubricant get into these incredibly small irregularities? The answer is surface tension, specifically low surface tension. Surface tension is caused by the cohesive forces at the surface of a liquid that make the molecules want to stay together. In the bulk of the liquid, each molecule is surrounded by other liquid molecules and is pulled equally in every direction, resulting in a net force of 0. But the molecules at the surface don't have other molecules on all sides of them, and therefore are pulled inwards. This creates internal pressure and forces the surface of the liquid to contract to a minimal surface area, acting like a stretched elastic sheet. This surface tension is what allows some objects to rest on top of water, even though they are more dense. For example, if you were to place an iron needle flat on the surface of water, it would remain there. Its weight would be supported by the forces in the stretched surface. This is not the same as floating. You know how you can tell? Well, if you place the needle point down on the surface, its weight, acting on a smaller area, would break the surface and it would sink. Surface tension is also what allows some insects, like water striders, to run on the surface of water by denting the surface, just as we might if we were running on a trampoline. So what does this have to do with the ability of a lubricant to penetrate? Well, the best penetrating lubricants typically have very low surface tension. The forces that adhere the molecules of these lubricants to the surface of the metal are greater than the cohesive forces between the lubricant molecules themselves. This results in what is called capillary action. We've all seen capillary action in our everyday lives. It's the force that pulls water slightly higher inside a drinking straw inserted into a glass. The adhesion of the water to the walls of the straw causes an upward force on the liquid at the edges. And since the surface tension of the water wants to hold the surface intact, instead of just the edges moving upward, the whole liquid surface is dragged upward. This is exactly what happens with the penetrating lubricant. The relatively low surface tension means that the forces that adhere the lubricant to the metal surfaces will be greater. And as the lubricant creeps into those microscopic gaps between the surfaces, the surface tension brings the rest of the lubricant with it. This will allow it to work its way deep in between the threads of a frozen fastener and ease its disassembly. So what does the industry test to measure a lubricant's ability to penetrate? Well, some would have you believe that pouring the lubricant into a styrofoam cup and seeing how the lubricant eats up the styrofoam shows just how well it penetrates. But eating through a styrofoam cup has nothing to do with low surface tension, and absolutely nothing to do with the penetrating power of a lubricant. The test that is typically used to determine the penetrating power of a lubricant is known as the wicking test. In this test, the threaded end of the bolt is balanced vertically in a small pool of penetrant for 2 minutes. Depending on the surface tension and capillary action, the lubricant will begin to climb the threads of the bolt. After 2 minutes, the number of threads the lubricant has climbed is counted. The more threads the lubricant climbed, the more penetrating power it is said to have. The Sprayon LU103 high-performance penetrant is the very best in the industry at penetrating those microscopic spaces to loosen even the most stubborn bolts and metal surfaces. In our wicking test, LU103 high-performance penetrant outperformed all the leading competitors. The interesting thing is that LU103 high-performance penetrant will not only release frozen lugs, bolts, and other tight-fitting metal parts better than the competition, but it does so more safely with a higher flash point, dielectric strength, and temperature range. Naturally, prevention is the best strategy for dealing with frozen bolts. That is, don't let them get to the point where they're frozen in the first place. A good anti-seize, like Sprayon LU103 anti-seize compound, will keep your bolts and other metal parts from seizing up. But that's another video, which you can check out right here. Of course, if you do get to the point where your bolts are stuck, Sprayon LU103 Penetrant will get the job done better and safer than anyone else. To learn more about Sprayon LU103 Penetrant, Sprayon's full line of high-performance industrial lubricants and chemicals, and the Sprayon 5S system, please visit us at sprayon.com.